How can you estimate the linearity of an electronic mixer?
Well, for this you have some tools. And in this video I would like to present you one of these tools, the third grade intercept point, or short IP3.
Let's talk about linearity of a mixer. A mixer behaves linearly as long as the input power level stays below a certain threshold. As the input power increases, nonlinear distortion products become stronger. Especially so-called third-order intermodulation products interfere with your output signal. Here you can see an ideal mixer in action. We apply two sinus signals on the RF and LO input, both with a slightly different frequency. The mixer multiplies those signals and the outcome is an overlay of 4 different frequencies. We already know the LO and RF frequency from our input. After mixing process, we additionally get sum and difference parts, especially the difference frequency we are interested in, because from there we get pure information out of it. But here comes the reality. In practice, we got a lot of more occurring frequencies in our spectrum. Here an example, you see how many of them we get. And it's just around the LO frequency. Many more in the whole spectrum can be detected afterwards. In the table, you get an overview about the mathematic terms that give you the exact frequency and information about the amplitude and so on. The problem with these intermodulation products, they overlay the desired signals, making the mixer nonlinear and the outcome unclear. In practice, for example in radar systems, this can lead to ghost targets or other unwanted side effects. But what is our intercept point right now? For this, we have to look at the input powers. First, the idea is how much input power we can feed in the mixer until nonlinearity dominates. For this, we start with an input power axis. At next, we look on the power of the different outcomes as a y-axis. We imagine the mixer as a perfectly linear and draw our diagram output-input ratio of our unwanted signal. Secondly, we look at the increase of third-order intermodulation products. They rise from a certain point strongly linear. At the point these lines are crossing, we find our third-grade intercept point. It's a theoretical point because we wouldn't be able to get linearity until this point from the mixer. When we look at what input power the IP3 lays, we can see that the theoretical input power we can feed in our mixer until nonlinearity's behavior overweights.
So thank you for watching my video. If you have any questions left, feel free to ask me in the comment section. Goodbye, till next time.